Hello and welcome to my video on 2D vectors, and we're talking specifically about vector addition. Okay, so let's take a look at vector addition. Just first of all, looking at these rules here, these rules apply to all vectors, including displacement, velocity, acceleration, force, but not to scalars. So not to distance, speed, but yeah, to vectors. And there are more vectors than just these, and we're just going to talk about those during this unit. Okay, the main idea of 2D vectors is that you can add vectors tip to tail, which gives a resultant vector. So you have two different vectors that you add tip to tail, and you get a resultant vector. Two main math concepts that we'll be using for these angled questions is Pythagorean Theorem, which is c squared equals a squared plus b squared. And the second is right angle trigonometry, SOHCAHTOA, which is basically all the different functions like this. So sine of the angle equals opposite over hypotenuse. Cos of the angle equals adjacent over hypotenuse. SOHCAHTOA is just a way to remember these. Tan of the angle equals opposite over adjacent. So those three, and then any rearranged version of those. And we often use tan in real life situations and when we're adding vectors tip to tail. Okay, so here is our first question. Mr. Drager walked south 440 meters and east by 330 meters. What was his total displacement over the course of the trip? So what we're going to do is first go south by 440 meters. So I'm going to just convert that to centimeters. So that would be 4.4 centimeters. And I know this won't be perfect, but this is a rough approximation. And this is trying to show to you guys that you can measure and do this with a ruler and a protractor, and you'll get the same answer as if you did it with the math method. So you can do scale diagrams. That's the thing I'm talking about right now, scale diagrams. So south by 440 meters, that's what we just did. Now we're going east, which is in this direction, by 330 meters. So now we start at that same position. Okay, 330 meters, so we're going this way till about here. Okay, this is not a perfect diagram, but it certainly shows the rough idea, so that and that. And so then we get a resultant vector, which is still starting at the same location and ending at the same location, but it is going, whoops, here I'll try to draw a straight line. Let's see if this works. Okay, it's not a perfect line here, but I think it gives a rough idea. Okay, so that is our resultant vector. Okay, and unfortunately it's going to be really hard to measure this thing because it is at an angle and my computer thing here doesn't let me spin them around at specific angles. But what we can do is we can measure the angle here. So what we need to do is we need to find the angle. Let's rotate this right, I think, yes. And then I was able to get this very precisely in there last time, but for some reason it's not allowing me to do that right now. That's annoying. Okay, well, unfortunately, I can't show this very well, but you can imagine that if I had this in the right location, then it would look something like this, and you can kind of see what it would be, which is 36 maybe. I'm kind of approximating it here, but roughly, let's say 36 degrees. And then same thing with these here. If I could measure this purple side, that would be fantastic. But I can't just spin it, unfortunately. I can spin it part way, but I can only spin it on a 90. So I was able to get this to be more precise earlier. I don't know why it's doing this now. Okay. Well, that's all right. It gives the rough idea. Maybe if we... No, it won't matter. It won't matter. Okay, so it gives the rough idea. That's good enough. So we get 36. Now let's try to do this by hand. So what would we get if we did this by hand? Well, if this is 440 meters, and this is 330 meters, okay, to get the purple side, we can do Pythagoras. So we can go c squared equals a squared plus b squared, and we can go c equals the square root of a squared plus b squared, and we can say that those values are, in fact, the values that are given. So 440 squared plus 330 squared with the square root of that, giving our final answer. So where's my calculator? Here it is. We get the square root of that, so 440 squared plus 330 squared, and we get 550. Okay, 550, that's the hypotenuse side. Okay, now let's try to get the angle. Because it's a vector, vectors have both a direction and a magnitude, so we need to find that 36, but let's just do it the mathematical way. We can measure it, but we can also do it the mathematical way. So we have tan theta equals opposite over adjacent. Opposite is 330, adjacent is 440. Okay, now let's find theta, so we go like this. So tan -1 of 330 over 440, and I don't remember what this value gives us. So that would be this here. So we get 36.869. So I was pretty close with my measurement. 36.869 degrees. And so you can kind of see it's pretty close when we use the protractor. My drawing is not perfect, and my protractor isn't even going in the right place, but this gives you some idea. Now, your final answer should be written more like this. 550 meters, and then it says 36 degrees there, so that would be 36 degrees east of south. And actually, sorry, 36.9 degrees, because we got 3 sig east of south. So this is how we should have our final answer for this question. Okay, you could, again, if you measured it and you'd use the rulers like this and you could put it sideways, you'd get 5.5 centimeters, and scale drawing would give you the same sort of thing. Okay, so let's go ahead and try our last question here. We're going to do it quite similarly. Mr. Drager was sitting on a dog sled when 2 dogs harnessed together got scared by noise and started pulling. One pulled due north, and one pulled with that force, and one pulled due east with that force. So we can do it with kinematics, which is what we did here, or we can do it with forces. So one dog, here I'm going to just draw the dog sled with Mr. Drager on it, okay? One dog pulled due north with 200 newtons. Okay, the other pulled, excuse me, due east with 150 newtons. What direction did the dog sled move if it had an acceleration of that? And if it had an acceleration of that, what was the mass of the dog sled and Mr. Drager combined? So, first, what we have to do is we need to put these two forces together. Actually, let's draw this with a different color here. These two forces together. Okay, so what we're going to do is draw them tip to tail. So we've got that one, and we've got this one. We've got 150 newtons here. We've got 200 newtons here. And so what we're looking for is the resultant vector. That is in this direction. So what is the angle here, and what is the value of that resultant vector? It's exactly the same as the last question. So all we have to do is c squared, well, yeah, I'll write the whole thing out, equals a squared plus b squared. This is Pythagoras. Square root of a squared plus b squared. We're taking a square root of both sides. Then we put in the values, so 200 squared plus 150 squared inside that square root to get our value for our purple, which is the forces added together. Another way to say that is if we add, just thinking about a force situation, we will sometimes talk about it like this. F net equals MA equals adding all the forces together. Right? We did this in the last unit. So in this case, we're adding all these two forces together. So what we're calculating here is the F net. So this is the F net. Okay, so just be aware of that. We're going to talk about that in a second. Okay, the other part of it is finding the angle. So we've got tan of the angle equals opposite over adjacent. So theta equals tan negative 1 of 150 over 200. And so that will be whatever that answer is. So let's try both of those in our calculator right now. So square root of 200 squared plus 150 squared. So that'll be one of our answers, 250. And the other answer is going to be square root of 150 divided by 200. You could write it as a fraction, or you can write it as division, and it's the same thing. If you have an older calculator, you just can't choose to write it as a fraction because older calculators are dumb. It is the same, actually same angle as the last question. So 250 and 36.869. Okay, so now we can say, what direction did the dog sled move? Well, the dog sled moved in this direction, so we're going to say the dog sled moved, and we should actually round it to 3 sig digs, so like that. And we'd say the dog sled moved 36.9 degrees east of north. Okay, be very careful about the direction here. It's going north, and then it goes east of north. Okay. And for F net, it equals 250. Because we added all the forces together, that's this part, this side, the right-hand side. And that equals MA. Okay, now we're also looking for the mass of the dog sled, assuming we have an acceleration, which we do. So we're going to divide by the acceleration on both sides, which is 2.50 meters per second squared. I don't think I did that on purpose when I made this question, but here it is. It's going to equal 100 kilograms, which I guess is reasonable, but no, it's probably a little bit light for a dog sled and me. Yeah, oh well. Alright, hopefully this video helps you understand the basics of vector addition, and especially in the next video we're going to be talking about components of vectors. So we're going to take one vector that is already the vector, and we're going to take the two parts of it, the vertical and the horizontal parts of our vectors. So yeah, take a look at the next video if this one helped you out. Good luck!